This is part 7 in the video series on factoring polynomials, and in this video we're looking at outcome number 4, factoring the difference of squares. Now in this video we're looking at a new strategy for factoring polynomials. In the past we used factoring by factoring out the greatest common factor. We've looked at factoring by trial and error. We've looked at factoring using the box X method. What we're looking at today is using the pattern of a squared minus b squared to give us what the factors are without having to use trial and error or the box X method. So it's a really quick way of factoring out a polynomial without having to go through either trial and error or the box X method. All you have to do is, or all you have to be able to do, is identify whether the polynomial is in the form of a squared minus b squared, which is the difference of squares. You can see difference in this case means subtraction, and we are squaring the terms a and b. So as an example of what that looks like, here is a polynomial that is in the form of a difference between two squares. So the a in this example is going to be, get my pen here. The a in this example is going to be x because that's what's being squared. So this is our a term. And our b term in this case is going to be positive 2 because positive 2 squared gives us 4. And then of course the subtraction here is most important. So if it's in the form of a squared minus b squared, then we can use this pattern here to give us our factors. So a in this case is x, and b in this case is 2, and then we want to do a minus b, so that's going to be x minus 2. And those become our factors for x squared minus 4. And if I wanted to check that, I'll use FOIL, and x times x gives me x squared, x times negative 2 is negative 2x, 2 times x is positive 2x, that cancels out those because negative 2 plus 2 is 0, and 2 times negative 2 gives me negative 4, and you can see here that that becomes x squared minus 4. So if you're able to identify that a polynomial is the difference of squares, then you can use the template of a plus b and a minus b as the factorization for this. Let me give you another example. It says factor 81x squared minus 49. So first of all, is this the difference of squares? Can 81, is there a perfect square for 81? And there is. That's going to be 9. So the a term in this case is 9x because 9x squared is 81x squared. 49, is that a perfect square? And it is. 7 is the square root of 49. So our a term is going to be 9x and our b term is going to be 7. So using the template for the difference of squares, our factors in this case are going to be a plus b, which is 9x plus 7, and a minus b, which will be 9x minus 7. And then if I were to do my check, 9x times 9x is 81x squared, and then 9x times minus 7 is going to give us a negative 63x, and then positive 7 times positive 9 is positive 63x. Those cancel each other out, and then 7 times negative 7 equals negative 49. So simplified, this becomes 81x squared minus 49. So these are the factors for 81x squared minus 41. So again, if you are able to identify the polynomial as the difference of squares, then the fastest way to factor is by using this strategy of a plus b, a minus b, and using that. Now, this concept leads us to the idea of repeated factorization. In repeated factorization, we still have the difference of two squares, except in this case you can see here that our degree for the x term is 4. So just a little bit different. but we still have the difference of two squares. So you can see here that we're still subtracting, so that's the difference. And if we were to do the square root of x4, we would get x to the power of 2. So x to the power of 2 times x to the power of 2 is x to the power of 4. So we just find the square root of x4, and that's our a term. And our b term in this case is going to be the square root of 81, which is 9. So our terms now are x squared and 9. So when we look at using the template of a plus b and a minus b, we'll get x squared plus 9 and x squared minus 9 as our factors in this case. Now, once we have this x squared plus 9 and x squared minus 9, you can see here that we have another difference of squares right here. So we just have to do one more level of factorizing. We want to factor this, and that's going to give us x plus 3 and x minus 3 are the factors of x squared minus 9, and then we just need to tag on, we can't forget this, x squared plus 9. And those are the factors of x to the power of 4 minus 81. I'll show you another example. Here's another difference of squares. The a term in this case, we want to square root this, so that's going to be 9x squared. That's going to be our a term, and then our b term is going to be the square root of 16, which will be 4. So that's our b term. And then if we were to use the pattern of a plus b and a minus b, our factors become 9x squared plus 4 and 9x squared minus 4. And this one here is again the difference of two squares, so I'm going to factor that out a little bit more, and that's going to give me 3x plus 2 and 3x minus 2. And then we just bring this down here, because that's the other factor in this case, because we are looking at a fourth degree term. So the factors for 81x to the power of 4 minus 16 are 9x squared plus 4, 3x plus 2, and 3x minus 2. So repeated factorization is just an expansion on the concept of the difference of squares. You just have to remember to use the template, but then further expand this factor here, because you do get another difference of squares while you're doing this. So again, when you're factoring the difference of squares, using this template here, using this rule, whoops, here's the rule, a squared minus b squared is the difference of squares. You can factor it by using the pattern of a plus b, a minus b, and it works great. For these types of polynomials, the difficulty is just making sure that you can identify when you do have a difference of squares, and if you do have a polynomial to the fourth degree that falls under the difference of squares, you can also use this rule as well. It's a great rule that takes out the need to do box X method or trial and error. And that's it for this video. Thank you for watching.